Welcome back to another YouTube Tuesday. My name is Derek, and today we're going to be going over a channel that I haven't reviewed but is a good source for repair in general. And that channel is Rewa Technology. Today we're going to be watching a video titled Fully Repair iPhone 14 Pro Won't Turn On, Motherboard Short Circuit. So let's get into the video. We're going to be watching it without audio so that we don't have any issues with music copyright. So feel free to check out the original video on their channel. I'll have the closed captions turned on so that we can see what they say, and I'm going to give my feedback along the way. So let's get started. Looks like they've got a package with a phone, iPhone 14 Pro. Nothing happens with the power button. Or a charging cable. Looks like they're going to go straight for removing the motherboard or connecting a power supply to the motherboard. And immediately you can see that it's got a short circuit. It's drawing power. So we're going to go over to their schematics, board view, and starting with a battery connector. There we go. They're finding the short. It's associated with any of the components in red. Very basic diagnosing stuff right here. There's a lot of components that could go wrong. There's no 5G antenna on this board. It must be international because they would have to take the battery out. We're going to inject power into that line and you can see where it's heating up. Looks like it's coming under the top layer. It's probably going to be a PMIC given where the heat was coming from my experience. They're going to remove the sponge connector protectors, and it looks like they're going to remove the back graphite heatsink. Putting it on a board heater at 170 Celsius. And they're going to warm it up with a hot air to pop the boards off. I wouldn't do it this way necessarily. I would heat it up a little hotter and not use any heat from above, but that works just fine. It's a good idea to remove the thermal paste anytime you're going to be reballing the two boards because otherwise you'll get a teeter-totter effect. And they're going to check to see if the short's still on the top board now that it's separated, and it is, because there are other components that could have been on the bottom board. And look at the heat coming right from the PMIC. And if you look at that, there's definitely damage and a crack going all the way up the PMIC there, so they're going to need to remove it and replace it. It looks like they're scraping off the underfill with 340 degrees Celsius. Now these little resistors along the side are really close. You have to be careful not to knock them off. And this little hook tool, he's breaking off the PMIC. You have to be careful with the temperature here to not heat up the board too much. Adding some flux and some medium solder to help mix with the factory solder. So they're going to be able to wick this much easier. Taking some wick with a big soldering iron, and they're going to wick clean all of the pads. And cleaning it up with some PCB cleaner. It looks like they did knock a resistor there. They're putting it back, adding some flux, spreading it out evenly. And they've got a new reballed PMIC. And they're going to get the position of pin A1 so they can line it up in the right orientation with the dot in the corner there. And they're going to heat it up and nudge it when it's soldered down just to get it to snap back into place. This is very standard how to do it. So now they're going to test for the short, and look, you get a 347 reading, which is right where you should be for that circuit. Now they're going to wick off all of the pads for reballing the mid layer. I recommend adding a low melt to help during this process beforehand. Oh, they're testing it as well just to make sure it boots with a jig. It compresses the top and bottom boards together. Now they're getting a stencil out to reball the midframe with some low temperature solder paste, probably like a 148 or a 158. And they didn't show peeling away the stencil, but they peeled away the stencil to leave the solder paste. And they're heating it up nice and slowly to 170. And you'll see all of the solder melt and form those nice solder balls. They'll clean up all of the paste and flux. Then they're going to add some fresh flux around the border. This helps prevent the balls from oxidizing. And now they're going to place the top board back on, heat it back up, and they'll probably take a heat gun to it, even though I don't do it that way. He's nudging it into place, making sure it snaps back. And then he's cooling down the motherboard with a little blowgun, putting back the foam protective connector protectors and then the back. And they're installing the motherboard into the phone, cleaning up all the evidence that you've been in there. And removing the camera protectors and then reinstalling it. And now it comes on. And they've got Wi-Fi and Bluetooth and sounds and haptics and Face ID and service. So yeah, that's a very quick and somewhat straightforward process on how to diagnose and fix an issue on a motherboard. First, you start with the battery connector where you inject power. And you can trace it back from there by checking the different lines, by isolating lines, for example, or isolating layers of the board. By splitting the two boards, you can find whether or not the short's on the top board or on the bottom board. And sometimes you can just visually check. If you were to look long enough, which shouldn't take you too long, you could actually just look at the PMIC and see the damage and go, there it is, need to replace that. At least you need to replace it to even see if there's anything else going on. There's a couple things that I would have done differently. For example, if I'm able to split the mid-frame perfectly, I don't worry about reballing it, because if I've split it perfectly, there's no point in worrying about reballing it. You just have to make sure that you add the proper amount of flux and remove the thermal paste just so you don't get that teeter-totter effect. However, you can leave the thermal paste if you want to have a clamping fixture on your heat plate so that you can put pressure on the spacers that are naturally there from the factory. Now, if you wick it, you remove the spacers, you can't put any pressure on the motherboard after you reball it. It just won't work. But yeah, that sums up today's video. Rewa, however you say it, definitely takes their time to make sure that their videos convey the majority, if not all, of the information that is necessary to do these types of repairs. So they're a great source when it comes to repairs like that. So definitely go and check out their channel. And hopefully this has inspired you to take a look at some of the devices that come in with no power, actually try to fix them instead of selling a customer a new device. Sometimes it's really simple. Sometimes it's just a single capacitor that's failed. And tracking that down isn't actually that hard once you understand the concepts of starting with a basic fundamental understanding of how a logic board works, where the power goes in and where the power goes from there. It can get really complex if you start to learn about the actual individual integrated circuits. But if you're just looking to follow a map to get from one point to another, and you understand some basic principles like how to use a multimeter, how to use a power supply, and how to click through a board view and potentially look at a schematic itself, fixing something like this is actually quite simple. If you have any questions, leave them in the comments below. If there's a video that you'd like to see me review, let me know in the comments as well. Thanks a ton for watching. We'll see you in the next video.